Today I am going to discuss the third session of dual nature of matter called Compton effect and its significance. Before going to discuss this, the topic which is discussed in the previous session is photoelectric effect, experimental study of photoelectric effect, experimental results, Einstein's photoelectric equation, Einstein's experimental results and its physical significance. Now recall what we discussed in the previous class. First one is photoelectric effect. Actually, photoelectric effect means when light of suitable frequency is incident on the metal surface, electrons are emitted from the metal surface. This phenomena is called photoelectric effect. It is one of the type of electron emission because there are four types of electron emission present: thermionic emission, photoelectric emission, field emission, secondary emission. Photoelectric emission is a type of electron emission and the phenomena is called photoelectric effect and it was discovered by Heinrich Hertz. Then we discussed experimental study. Briefly think about this. There is an evacuated glass bulb which has two electrodes, cathode and anode. Cathode is connected to the negative terminal of the battery. Anode is connected to the positive terminal of the battery. The cathode has a side tube provided with quartz window through which radiation enters. As soon as radiation falls on cathode, immediately photoelectrons are emitted. These electrons are moved towards anode, current generate, recorded by ammeter, micrometer or ammeter, current meter, etc. Then using this, some of the experimental results that are discussed. One, photoelectric emission is instantaneous process. That means as soon as radiation falls on cathode, immediately photoelectrons are emitted. The time difference between the radiation incident on the cathode and emitted electron is 10 power minus 9 seconds. Second one, if for every metal surface there is a minimum frequency of incident radiation below which photoelectrons are not emitted, that frequency is called threshold frequency, corresponding wavelength is called threshold wavelength. Result 3, if the frequency of the incident radiation is greater than threshold frequency, the photoelectric current is directly proportional to the intensity of incident radiation. A graph is drawn by taking current against intensity. It is a straight line. And result number 4, if the frequency of the incident radiation is greater than threshold frequency, the maximum kinetic energy of photoelectrons increases by increasing the frequency of incident radiation. It is again a straight line if a graph is drawn by taking kinetic energy of electron along y-axis and frequency of incident radiation along x-axis. It is a straight line, but there is a gap in the graph. It is not passing through the origin because in that gap there is a minimum frequency below which photoelectrons are not emitted. In addition to this, I want to define a term called stopping potential. The stopping potential means minimum negative potential applied to the anode to stop the flow of electrons from cathode to anode. Then we will discuss in the previous classes Einstein's photoelectric equation. According to Einstein, the maximum kinetic energy of photoelectron is equal to energy of incident photon minus photoelectric work function. Given by the equation, maximum kinetic energy is equal to h nu minus phi, and it obeys the law of conservation of energy. Energy of incident photon is equal to photoelectric work function plus maximum kinetic energy of photoelectron. And the results which are discussed is the results of experimental study of photoelectric effect. What are the results, please? One, the result number 1 is photoelectric emission is instantaneous process. The second one, the frequency less than threshold frequency, kinetic energy is negative, photoelectrons are not emitted. The nu is equal to nu naught, the frequency of incident radiation just equal to threshold frequency, photoelectrons are just emitted. The corresponding energy is called work function, pi is equal to h nu naught, kinetic energy is equal to 0. If the third result, frequency of the incident radiation greater than threshold frequency, the photoelectric current is directly proportional to intensity of incident radiation. And the last one, frequency of incident radiation greater than threshold frequency, maximum kinetic energy of photoelectron increases by increasing the frequency of incident radiation. These are all the topics which are discussed in the previous class. Okay, we want to discuss today is Compton scattering. When a monochromatic X-rays are scattered by solids like carbon, in the scattered radiation, in addition to the original frequency, which is always less than the incident frequency, appears in any given direction of scattering. The effect was explained by Compton on the basis of quantum theory of radiation, and this effect is called Compton effect. Now, I want to derive the expression for Compton wavelength and its significance. The process of scattering is schematically shown. Let E1 and E2 be the energy of the photon before and after collision. P1 and P2 be the momentum of the photon before and after collision. Pe be the momentum of the electron. By the conservation of linear momentum, vector P1 is equal to P2 plus Pe, or vector Pe is equal to P1 vector minus P2 vector. Now we are taking the dot product of this equation 1. Pe dot Pe is equal to P1 minus P2 dot P1 minus P2. Then Pe square is equal to P1 minus P2 whole square. If you simplify this, Pe square is equal to P1 square plus P2 square minus 2 into vector P1 dot vector P2, or Pe square is equal to P1 square plus P2 square minus 2 into P1 P2 cos theta, since vector A dot P is equal to AB cos theta. But we know the relation between energy and momentum using Einstein's mass energy relation. E is equal to mc square. You modify this, E is equal to mc into C, or E is equal to P into C, or P is equal to E by C. Using this equation, if we write the equation previous one as expressed as Pe square is equal to E1 square by C square plus E2 square by C square minus 2 into E1 E2 by C square into cos theta. In all terms, 1 by C square is common. If we take outside, Pe square is equal to 1 by C square into E1 square plus E2 square minus 2 E1 E2 into cos theta. Then from the conservation of energy, E1 plus m0 C square is equal to E2 plus C into square root of m0 square C square plus P square. Modify this equation, C into square root of m0 square C square plus P square is equal to E1 plus m0 C square minus C2 square, or square root of m0 square C square plus P square is equal to 1 by C into E1 plus m0 square C square minus E2 square. Squaring and simplifying, we get m0 square C square plus P square is equal to 1 by C square into E1 plus m0 square C square minus E square whole square. So modify this equation, Pe square is equal to 1 by C square into E1 square plus C2 square minus 2 E1 E2 times plus 2 into E1 minus C2 into m0 C square. You call it as equation 3. Then equate equation 2 and 3. If we equate equation 2 and 3, 1 by C square into E1 square plus C2 square minus 2 E1 E2 cos theta is equal to 1 by C square into E1 square plus E2 square minus 2 E1 E2 plus 2 into E1 minus E2 into m0 C square. Modify, E1 minus E2 is equal to E1 E2 by m0 C square into 1 minus cos theta. Now, according to Planck's law, E is equal to hc by lambda, E1 is equal to hc by lambda 1, E2 is equal to hc by lambda 2. Substitute E1 and E2 in the previous equation, we get hc by lambda 1 minus hc by lambda 2 is equal to hc by lambda 1 dot hc by lambda 2 by m0 C square times 1 minus cos theta. Simplify this, the equation becomes lambda 2 minus lambda 1 is equal to h by m naught c into 1 minus cos theta, or d lambda is equal to h by m naught c into 1 minus cos theta. This is the expression for Compton shift. Now using this, we want to discuss about the special cases. Case 1, when theta is equal to 0, cos theta is equal to cos theta is 1, then the above equation becomes d lambda is equal to h by m naught c into 1 minus 1, that is equal to 0. So d lambda is equal to 0, there is no changes of Compton wavelength. It is called a coherent scattering process because the wavelength of the incident radiation is equal to wavelength of the scattered radiation. There is no change in the wavelength. Case 2, if theta is equal to 90 degree, d lambda is equal to h by m naught c. Substitute, the value of h is 6.625 10 power minus 34. The m naught is 9.1 10 power minus 31. 3 into 10 power 8 is the value of c. The answer is 0.0242 angstrom. This is the value of Compton wavelength. Case 3, if theta is equal to 180 degree, d lambda is equal to h by m naught c into 1 minus of 1 minus 1, 1 minus of minus 1, that is 2h by m naught c. The answer is 0.048 angstrom in it. Then physical significance of Compton effect. In the Compton effect, Compton shift explained on the basis that X-ray photons collides with electrons, and during the collision, energy between exchange occurs as though it is a kind of particle-particle interaction. Thus, it demonstrates the particle nature of X-rays.